Welcome to this Roundup. Over the years, many have wondered, what is the science of consciousness? Why does consciousness exist? Or how does consciousness exist? Or how to measure consciousness, and what are the different states of consciousness? The answers to any of these questions depend on our understanding of the philosophy and the science of consciousness in not only humans, but also in machines and perhaps in matter and Mother Nature. So how we understand its relationship plays a very important role. But as we see, even the term consciousness is itself caught in the endless explosion of meaning, and there is no agreed central definition of consciousness or even tools to measure consciousness. To discuss science of consciousness in man and machines further, I'm honored to welcome Professor David Gamez to this Roundup. Professor Gamez is the lecturer in computer science at Middlesex University and is author of the book Human and Machine Consciousness. I am reading this book currently. It's very interesting. His other publications include What We Can Never Know and What Philosophy, co-edited with Javi Carrel. He has also published many other papers and book chapters on philosophy, artificial intelligence, and neuroscience. Welcome, Professor Gamez. We are honored to have you on this Roundup.
Oh, well, thank you for inviting me. Yeah.
Wonderful, Professor Gamez. So, neuroscience hypothesizes that consciousness is generated by interoperation of various parts of the brain called the neural correlates of consciousness. However, it seems there are challenges to that perspective. Now, proponents of machine consciousness believe that it is possible to construct systems, for example, computer systems, that can emulate these neural correlates of consciousness interoperation and interrelations. Where is this general consensus on consciousness, going?
I don't know where it's going. I'm not sure anyone knows where it's going. I mean, firstly, a lot of people obviously believe that consciousness is kind of caused by the brain, which brings up a whole load of philosophical problems. And so one of the reasons Crick, who came up with this neural correlates idea, came up with correlates rather than causation is to say, well, let's not try and talk about causation because there's the hard problem of consciousness, all that kind of stuff. Let's just talk about correlation and see what is linked to what. In a very neutral way. So we're not trying to say that the consciousness is caused by, neurons buzzing around, whatever, because we have no idea how that could work. But we can at least study, the relationship between, our conscious experiences and what's going on in the brain, and then maybe relate the two systematically. That's kind of the objective of all that. So that's scientifically tractable, which is why Crick liked it, and why I like it too. But in order to do that kind of work, you've still got to, there's still a lot of work to do, right? You're just framing the problem. You're not solving the problem. Yeah.
Very true, very true. We have framed the problem, but there is still a lot to be done. You're right about it. Now, while human mind seems to be a set of cognitive faculties, I mean, that it includes consciousness, it includes perception, thinking, judgment, memory, so many of them. So it seems, like you say, they're all in, we need to understand the interrelations and interconnectedness. So we still don't have a clear understanding of all the cognitive faculties that will give us a clear understanding of neither the human intelligence or human consciousness. So when we say a person is conscious or when we say a person is intelligent, is there a credible approach to measure consciousness or even intelligence?
Okay, well, I mean, I've just started working on intelligence, but I'm happy to talk about that later. I mean, just the two are quite separate in a way, right? Yes. So in terms of measurement, so the question was, is there a credible way of measuring consciousness, right?
Yes.
So obviously there's very credible ways of measuring consciousness in terms of the external behavior of human beings, right? That, I'm looking at you now and, you're alert, right? Talking to me, there's a bunch of sort of things like the Glasgow Coma scale or other sort of measures people put forward about how external behavior in humans can be used to infer their consciousness, right? And that's all totally standard. We use that all the time in our day-to-day life. If you're lying on the street, asleep or something, then I'd infer that you probably weren't conscious, right? Unless you had rapid eye movement or something like that. So in terms of external behavior, of humans, we've kind of covered that. But measurement of consciousness in terms of external behavior becomes much more problematic when we switch to, I don't know, let's say birds or fish or octopi or something like that, right? Because we can't, because the same functions, shall we say, that are associated with consciousness in humans might be implemented in a totally different way in octopi, for example. His brain architecture is very different, right? We kind of have a hunch they might be conscious, but we can't just naively use that external behavior to measure consciousness in those animals. And that's why there's lots of papers and debates and discussions about whether octopi are conscious. And I commented on some paper on whether fish are conscious, and this stuff goes on and on. Yeah. And then when you go to machines, let's say robots or something like that, you have people again sort of will try to naively take external behavior that looks like external behavior and attribute consciousness to it. But in case of machines, you can't do that at all, because with a robot, you could implement any old set of behavior in many, many different ways, right? It's a lookup table, a database, recorded behaviors, whatever, right? So there's no reason in robots, for example, to try and make some kind of inference from external behavior to the actual internal consciousness. That's a mistake people often make, I think. So then we get to the other approach people have been taking to measuring consciousness, which is kind of touching on this kind of neural correlate stuff, right? That we try and look at what's going on inside the system, and if it looks like what's going on inside the brain when we're conscious, then we can use that to make predictions about consciousness in other systems. So at least in my own work, the general path is to start with systems that we believe are conscious, like human beings and monkeys and most mammals probably. We're really confident about that, right? So when let's say a monkey behaves in a way that we behave, that in the same way that we behave when we're conscious, we attribute consciousness to that monkey, right? Yeah. And then we can look inside the brain of that monkey or person and measure and try and find what's correlated with consciousness. So there's a whole bunch of research on the neural correlates of consciousness, as you said. And we might be able to find, there's theories about global workspace theory, theories about hot zones, theory about recurrent connections, a whole bunch of neuroscientific theories about that. And so if we could figure out, what was actually going on in the brain when we're conscious, and isn't going on when we're unconscious, then we might be able to look inside an octopus's brain, for example, or look inside, potentially even a robot's brain, and see it's got the same stuff going on. That's the general idea. And then there's a whole, I don't want to layer too many layers of complexity here, but there's a lot of, the problem is that if we're starting with humans, that's kind of like biological wetware, right? It's a bunch of squidgy neurons and a load of chemicals flowing around in the blood and all this kind of stuff. So if we get too narrow a sort of interpretation of what's linked to consciousness, we're never going to be able to generalize it to kind of birds or to robots or anything like that, right? It's going to be just very specific human neural correlate stuff. So we need to somehow figure out a way of understanding the relationship between consciousness and the brain in a way that we can then take what we know about that and then generalize it to, octopi and birds and infants and robots and all that kind of stuff. And that's actually turns out to be kind of quite a hard problem, and no one's really solved that. The sort of the approach that a lot of people like, which has a whole bunch of problems of its own. I'm sorry, mainly going to give you problems in this talk, yeah. The approach that a lot of people like, because it's generalizable, is Giulio Tononi up in Wisconsin. He's come up with this thing called an information integration theory of consciousness, where it's a kind of an algorithm, and it measures you apply the algorithm to the sort of state transitions of a particular system, and it's all based on information states. And then using this algorithm, you can then generate a prediction about the consciousness in the system and what it's conscious of and all this kind of stuff. It has many serious limitations, such as the fact it's based on information, such as the fact that it's got these factorial dependencies. But a lot of people are attracted to that because if you could prove that it worked in the human brain, you could then apply it to any system you liked, and actually, it would be generalizable. Probably information integration theory isn't correct as an algorithm, but most likely it's the right kind of approach. It's the right sort of thing I think we should be looking for, which would enable us then to prove that a particular algorithm works on a human, on maybe electromagnetic waves or something like that. And then we could then build a system that, we could then analyze it using that algorithm and then actually have some kind of generalizable theory of consciousness and be able to measure it in a sort of indirect way in other systems. That's the idea.
Yeah, that's very interesting, information integration theory. And I'm thinking, even if it's an algorithm, just like, genes, human body has all different genes. And when the genes express, it depends on, what is in the biochemistry, the whole ecosystem, internal as well as external. So there must be many variables which influences whether the gene, expresses the same way. There are probably, many variables that will influence how the consciousness will be expressed. Because if you see any single human being, at any time, the conscious behavior that would happen, in any particular moment, is different under different circumstances. Whether, someone, acts, consciously, or, in a different way, it depends on many different, perhaps, variables. That's what I feel. So even if we can figure out what algorithm, if it's, going to perform according to that, it's still probably, I feel that there are many different variables that will influence or that will play a role, because in recent years it's reported that the structure of the adult human brain changes when a new cognitive or motor skill, including vocabulary, is learned. So whenever humans learn something new, the brain changes, there are changes happening in the brain. So this changes the level of intelligence and nature of intelligence. So if you compare it similarly, or if you look at it from that perspective, is there any understanding about what defines the level of consciousness, or what defines the expression of the consciousness in humans or machines?
What define, well, the level. Okay, so I mean, I think people are fairly, in humans at least. I mean, I'm no neurologist, right? But as far as I understand, there's a sort of activation system, right, which would determine whether you're kind of capable of consciousness or not at a particular point in time. I think is it reticular activation system, something like that. Don't quote me on that. Well, you kind of are quoting me on that, but anyway, so in order for the so most people, and probably the latest work supports this, think that something like that the actual contents of consciousness is going to be in the neocortex somewhere, right? The sort of scrunched up stuff on the top of the brain. But in order for those neurons to reach the stage at which they're actively firing, then you need some kind of background activity being sort of pumped into them from deeper within the brain. And that's why you need, and so you have people, so if you destroy the activating system of the brain, then you never get any consciousness at all, kind of thing. So it's like an on-off switch, and that on-off switch, if that's damaged, you end up in a deep coma, and if it's and probably it goes on and off when you're into deep sleep and that kind of stuff. So in terms of level, then that probably is controlling the level to some extent. And then in terms of, and something I should have mentioned actually, is that there is work in terms of, I mentioned the external behavior and I mentioned the kind of algorithmic work, but there's some very promising stuff in the middle, where people are using a combination of transcranial magnetic stimulation, where they kind of hit the brain with a pulse of electromagnetic energy, and then they use EEG, which is kind of recording the resulting electrical activity of the brain. And they found that when they hit the brain with a pulse and then record the activity, the complexity of the resulting activity of the brain that results from that pulse correlates with the level of consciousness. So they come up with a sort of way of measuring consciousness in this way, and then they applied it to coma patients. This is kind of work of Casali, I think, in Milan, something like that. It's like a few years ago. I think I've applied it in various areas since then. So that's a sort of another way, of measuring consciousness, through kind of by directly stimulating the brain. And Tononi sort of claims it's consistent with his work, which it is, but it's in no way a proof of, information integration theory. So that's so in terms of the level stuff, probably we're talking things like the reticular activating system or whatever it is, which is kind of deeper brain structures providing the sort of electrical current effectively that means that the cortex will actually be at this sort of activation threshold kind of thing. And then in terms of conscious contents, well, most likely my best guess, which I wrote in a paper a few years ago, is that, and it actually is very consistent with this hot zone stuff that Cox come up with recently, is that particular kinds of patterns in the neurons are correlated with different kinds of experiences. That's my best guess about that, right? So obviously there's a different qualitative character to neurons being activated in my audio cortex rather than my visual cortex, right? And the character of those cortexes is largely a result of, well, at least in ferrets, because they've done these experiments in ferrets, is due to the sort of the types of stimulation that you get on those different cortexes. So if you stimulate a piece of cortex that doesn't have any kind of patterns in it, whatever, hasn't learned anything yet, with audio information processed through the air with all its spike conversion stuff, then you're going to get one kind of pattern impinging on that cortex, and that cortex will learn that kind of pattern and then develop patterns of its own that respond to those kinds of incoming auditory patterns. And the same is true on the visual cortex. And so one of the experiments that sort of illustrates that is with ferrets, young ferrets. I think ferrets in the womb even, can't remember the details, but they swapped around the connections from the auditory and the visual, and they showed that the parts of the brain, the ferret's brain that received the visual signals, even though they're originally auditory, they developed the same kind of response characteristics as the visual ones would have been if the visual data had been in a normal place. So this kind of suggests, since consciousness is clearly correlated with these parts of the brain to some extent, that the character of the patterns, which is largely learnt by sort of stimulation, is probably linked to the different qualitative character of the consciousness that's associated with those states. So if you wanted to reproduce them, I suppose robot or something like that, you'd have to reproduce those kinds of patterns. But we've actually got no idea what those patterns are really. I mean, and just more generally about that kind of stuff. So why people like Tononi's theory is because it has a compact, simple answer to the relationship between all of the enormous complexity of the brain and all of the enormous complexity of consciousness, because you just apply that algorithm, even though you can't apply it for various technical reasons, and then it will generate a representation of the state of consciousness. And that representation of the state of consciousness will be different for each different state of consciousness. That's why people like it. But it's, as I said, it's massively flawed. So, but as an ideal, it's not a bad one, yeah.
Yes, no, it's very interesting, and I think you are probably right on that, because it's the brain waves, right? So when you have the bombardment of electromagnetic waves, then it does influence the level of consciousness, and that makes me think that with this 5G and all these advances that are happening in the digital global age, and with so much electromagnetic radiation and electromagnetic waves are all around the humans, what is going to be the impact on all the humans? I'm just thinking about it, because after all, it's the brain waves, and when the electromagnetic waves hit it, it does impact. So if not now, in 5 years, 10 years, what's going to be the impact on human consciousness? That is something, I hope that someone studies that, because there will be some impact in the coming years. Now, in a human mind, it seems consciousness and intelligence is equal to creativity, perhaps. I mean, these are all theories, so I cannot say for sure, but I read that it's equal to creativity. So in machines, at this point, it seems we may be able to create some level of intelligence and awareness. There is awareness in machines, because if you ask them what time is it, they're able to tell us. We ask whether machines are able to tell us. So it's this sort of awareness. So is that considered consciousness? Can we consider that as a consciousness? And how can we develop mathematical theories that can make believable or reliable predictions about consciousness? I was reading in your book, you have done some work on that.
Yeah, so it's sort of several topics, right? So, I mean, roughly speaking, I guess we do a lot of so you've got these sort of three things, right? You've got creativity, consciousness, and intelligence, right? So all of which, well, consciousness, I think, can be fairly clearly defined, right? I mean, at least in my own work, consciousness is, a kind of what I define as a sort of a bubble of experience, right? That when we're conscious, we're immersed in this bubble of space, which changes and shapes in response to our environment. And I look out from my body into this bubble, this world, and see colors and shapes and tastes and all that. And that's what I mean by consciousness, right? And you can tell a whole story about the evolution of the sort of emergence of this concept of consciousness in response to certain developments in science in the 17th century and all that kind of stuff. So I think consciousness we can define very clearly as this kind of experiential world that we're kind of immersed in, which has, and obviously when we're fully conscious, that world is kind of richly colored and, high resolution, all that kind of stuff. But sometimes if we're in a dream, it's much more fleeting and unstable and has lots of different kind of levels of consciousness and different characteristics of consciousness. And so within our conscious experience, we can do different stuff, right? We can, do paintings, we can do all that kind of stuff. And so then you're going to get into kind of creativity. And so I wouldn't necessarily say that there was, some people would say potentially, but the evidence for this, I think, is waning, that, there might be some kind of link between being creativity or the kinds of structures that are needed for creativity and the kind of structures that might be needed for consciousness, right? So some would say there's a very popular theory about consciousness called global workspace theory, which is like, it's based on this old sort of blackboard architecture, which is quite a good way to think about it, that you have a sort of blackboard if you like, and lots of competing sort of small, and the blackboard is the kind of conscious stuff, and then you have a bunch of kind of competing small unconscious processes that do different kinds of things, yeah? And very loosely, the different unconscious processes compete, and the one that's got the most sort of important stuff to say puts its stuff on the blackboard, and then that gets broadcast back to all of the other processes, and then they get that new information, and they do more stuff, and then they compete again, and you have this cycle of competition and broadcast and competition and broadcast. So you might think, within the context of that kind of theory, that maybe creativity or intelligence or something like that, some kind of flexible intelligence, is linked to consciousness. So, as I said, it's a popular architecture, but I'm a little doubtful about it because of these more recent results in the neural correlates of consciousness, which suggests that consciousness is actually more localized. It's not necessarily this whole global brain broadcasting stuff, but the jury's a little bit out on that. So if you buy into these kind of theories of consciousness, and there's Edelman's reentrance stuff, and there's other sort of recurrent connection theories, then you might make some kind of connection between tasks that we can only do consciously, which is kind of fair, right? There's a bunch of things we can only do consciously. But whether those things are intelligence or whether those things are creativity is a little bit questionable, right? Because you often, have an idea that just pops into your head, right? So there's obviously an unconscious component to creativity to a large extent, I think. So there's obviously some kinds of reasoning which initially we can only do consciously, and so those are probably linked to the mechanisms that are linked to consciousness to some extent. And there's a bunch of other stuff that we can do unconsciously, just as well. And then intelligence, I just started work on this. So I've got a strong hunch so intelligence is sort of multifaceted. Again, one of these multifaceted concepts, people mean different things by it, but there's a sort of fairly strong strand of intelligence is to do with prediction, I think. So the ability to generate, given a set of inputs and your bodily actions, how far can you generate predictions, accurate predictions about your environment, based on that? And that's kind of very much linked to planning, right? That we can take the current state of the world, and then we can plan to reach another state of the world by generating predictions about what would happen if we did different things under different circumstances. And there's lots of elements of prediction in IQ tests, for example. So, and quite a few people within AI, for example, as well, think that, prediction is kind of a good way of capturing one very important aspect of intelligence. And I kind of buy that too. So the kind of conscious planning, again, is utilizing a lot of prediction, right? If I'm trying to think about how to get to the shops, for example, I might, imagine going to the corner of my street, and then I'll imagine turning left, and I'll imagine turning right. I'm doing a whole bunch of different predictive steps in order to reach my goal. And we'd use that kind of reasoning in, lots of different areas. If I'm imagining a new sculpture I'm trying to build, again, that's linking up to the creativity. I might imagine different sides of it and how I might cut it and all that kind of stuff. Or if I'm a sportsman, I might imagine, running the race in different ways and all that kind of stuff. So there are obviously connections between consciousness, intelligence, and creativity, but also in some circumstances, I think there's a dissociation between them, right? So there may be some underlying mechanisms that are linked to consciousness and that enable creativity and intelligence, but at the same time, we could quite easily build, the standard machine learning stuff is very predictive, it's very intelligent, but I wouldn't be particularly inclined to attribute much consciousness to it, right?
Yeah, so you think that computational architecture, that means the algorithms and all, that plays a key role, because you said it's localized, right? Consciousness. Your theory is more towards it being a localized. So does the algorithm, play a key role in the consciousness? And then if it is the case in machines, then DNA is also sort of like an algorithm. So is that what is playing a role in consciousness? And then it's genetic that, there is no environmental role that impacts the genetic, nature of the algorithm? Is that where the theory is going, that it is consciousness is genetic and hereditary?
Well, okay, so the algorithm, so there's two sort of aspects to this, yeah. So I'll try and get to the question about genetic heredity in the end, yeah. But so the algorithms that are being put forward, like Tononi's information integration thing or my own liveliness one, they're trying to measure what's going on inside the brain when it's conscious as opposed to when it's unconscious, in order to be able to generate a prediction about that, yeah. So it's taking, it's not saying it's not saying what algorithm the brain is implementing. It's trying to just interpret the states and see if it can generate a prediction about that, yeah. So for example, back in the day, people used to believe that synchronized neurons, right, neurons firing in synchrony, were linked to consciousness. So you could write an algorithm that would measure whether neurons are synchronized or not, for example, and then that would enable you to predict consciousness if that was indeed the relationship. But that's pretty doubtful. No one really believes that anymore, I don't think. But that's kind of but just because they're synchronized doesn't tell you what they're actually doing, if you see what I mean. Yeah. And then the other kind of algorithm you might want to talk about is what the brain is actually doing when it's conscious, right? And so there's a whole bunch of, in my opinion, bad functional and computational theories that, consciousness is linked to attention, or consciousness is linked to higher order thought, for example. Theories about the sort of the cognitive functions that are going on inside the brain. And then a lot of people believe that those cognitive functions could then be implemented in a computer, and then that computer would also, be conscious to some extent. Yeah. So that's sort of a different kind of algorithm from the algorithms that are being used to measure consciousness. Yeah. So, and there's the reason why I don't believe in any of these computational functional theories is because it's too easy to write 20 different kinds of program that produce the same kind of function. Yeah, there's a sort of massive multiple realizability problem. So you kind of need to make your conscious machine. You kind of need to implement your functions in the same way that the brain is implementing those functions. If they're, so there's a whole bunch of work on what's called neuromorphic chips, where they're using. So your standard chip just has a bunch of like instructions, right? Like copy this number to there and multiply this number by, another number, all that kind of stuff. So they've got nothing really to do with how neurons work. And so if you write a simulation of the brain using standard chips, you're producing a system that physically is radically different from a brain. Whereas with a neuromorphic chip, it's designed just to simulate neurons or emulate neurons. So you have like the flow of electrons within the chip kind of mimic the flow of ions within the actual physical neuron. And so the electromagnetic waves, at the very least, produced by this neuromorphic chip are made much similar to the electromagnetic waves in the brain. So it's a much more plausible candidate for the kind of system that could be linked to consciousness. And in terms of the genetics, I guess, well, firstly, obviously the genetics don't determine, are at best going to set up a system that might be capable of consciousness. Then obviously the genes themselves are probably too slow acting and to actually be, turned on and off. It's more likely a high level activity of the whole system that's produced by the genetics, I guess, right? And obviously you can have the same genes and be conscious and unconscious at the same, at different points in time. So probably there is a genetic component to set it. Well, obviously the genes set up the initial state of the brain, and I don't know what would happen. Because all the natural experiments on brains that are not cultured have still been exposed to environments, right? So I don't know if we've got any data on brains that had the genes, if you like, but but that matured in the complete absence of environment. I mean, not only would that be massively unethical, right, but I don't know if they've done it in mice or something. But then even then, for example, those experiments I was talking about earlier, where they were exposing the ferret's cortex to the stimulation patterns, a lot of the training of that was done in the womb, because in the womb you still have these noise patterns happening in the ear circuits or whatever, in the retina and that kind of stuff. So you're still getting vision-like stimulation of the brain and auditory-like stimulation of the brain, as well as a limited amount of light filtering through the stomach of the woman and a limited amount of sounds filtering through. So even if you tried to completely isolate a brain from its environment, you'd struggle basically, and so it'd be difficult to know whether the correlates of conscious stuff will get set up entirely by genetics, or whether you'd need some kind of, because you can't get rid of the environment at all easily, right?
Right.
Except maybe the only example would be the experiments that have been done growing brains in growing cortex tissue in petri dishes, right? So there've been some stuff done on that, so you could see whether, if you've got a whole bunch of neurons without any stimulation, they probably wouldn't self-organize into the kinds of patterns that we think might possibly be linked to consciousness. That's only a guess.
Yeah. Right. No, I hear you on that. I think while it could be genetic, environment definitely could be playing a role. The reason is, I was reading a report, recently on some supplements that people take, and when they take those supplements, they get a lot of dreams. They get more dreams than they were getting before, and they would remember the dreams. And that all these different states of consciousness, like sleep and alertness, or dreaming and meditating. They are all, different sorts of consciousness, and it happens under different environmental conditions. So whether the conscious mind is simply a function of brain activity, or is it a non-physical material substance, or it gets influenced by the biochemical environment, or even the electromagnetic environment, all those things perhaps needs to be studied more to be able to come to some sort of conclusion. But it seems that science recognizes that there are many different states of consciousness. So, what are the different states of consciousness that are more important? Are each of the different states of consciousness, playing a same role in human behavior, or you think that certain states of consciousness are more important when it comes to human behavior, or probably machine behavior, because the fear that is there that someday machines will take over and will not think of human, will not be loyal to humanity, and that it will destroy humanity. So if we are developing machine consciousness, then what is the level of that consciousness, what is that nature of consciousness that we need to be mindful about to for the future of humanity, to protect humanity in the coming years?
Okay, so just a couple of comments on the initial stuff. So clearly the chemical and electrical environment has a massive effect on our consciousness, right? So hallucinogens, to pick an extreme example, right, completely mess with consciousness and provide wild hallucinations and that kind of stuff. And if you take anesthetics at the other extreme, right, it completely knocks out and just eliminates consciousness. So there's clearly a very tight, the brain's very sensitive to certain kinds of chemicals that affect the transmitter properties, all this kind of stuff. And regardless of your position on dualism and second, all that, given that there's a correlation between states of the brain and states of consciousness, if you mess with the brain with various kinds of chemicals, your consciousness changes radically as well. And then to kind of jump to the end of what you were saying in a way, so I mean, I don't personally, what states of consciousness are important from a human point of view obviously depends on, what humans think are important, right? I mean, if I was religious, I might think that, religious experiences were, more important because they told me about God and my relationship to God and all that kind of stuff. Or if I wasn't monotheist, I might believe that, other kinds of, sort of experiences of union or whatever would be, very important in terms of, the trajectory of my life. Or, if I wasn't religious, well, I'm not religious anyway, particularly, but then, so there's everyone has their own sets of important experiences that are, important to them, right? I wouldn't personally place a judgment on, whether one or another is better or not. But relating back to the question of, machines destroying humanity stuff. So supposing we were, so the first point about this is, machines probably aren't going to destroy humanity if they're only based on deep learning, right? So there's, deep learning is very limited technology that's had a lot of local success, but it's not the kind of thing that could produce the kind of flexible cognition that without, the kinds of, one-shot learning and prediction and reinforcement learning, all that kind of stuff that humans can do, deep learning can't do, right? There's a bit of overhype of this kind of stuff, yeah? So, but let's suppose we did build machines that were more like human thinking, but just much more powerful, right? So they had the kind of flexibility and the kind of the consciousness in the sense that they had a sort of single stream of awareness containing stuff. But let's suppose that they had massively more data, so they were much more powerful at thinking than we are with our very limited brains and our very biologically constrained, hardware and all that kind of stuff. Yeah. And then you get the question of, well, what do the machines do, right? And this kind of links up with the kind of intelligence or decision-making stuff, which is what I'm moving into now much more. So I think you have to make a distinction between intelligence, which is the ability to sort of predict or, have a certain knowledge of the future, right? Which machines are getting better at, right? Deep learning is good at that stuff when it's got the data. And then a sort of decision about, what's a good state and what's a bad state, or what goal you actually want to achieve at some point in the future, right? And that's the bit where you get more into the sort of threat of humanity stuff, right? So machines that simply predict, everything, if you like, in some godlike way, aren't in kind of threat, right? It's machines that do stuff or have decisions or agendas or this kind of thing that are going to pose some kind of threat. And in humans, at least, I mean, I think that the best way of thinking about that, how we do that stuff, is through Damasio has this idea of somatic markers. So that when we sort of interact with the world, we experience things, and then some things have effects on our bodies in different ways. Right? We might feel afraid, or we might feel happy, or this kind of stuff. So we sort of sensory stimulation of various kinds triggers these feelings in us. And those feelings are, in a sense, our sort of evaluation of whether things are good or bad, right? They're sort of a felt judgment about the different states of the world that we experience. And those felt judgments might be hardwired in a very limited way in humans, right? We might be scared of spiders or snakes or something like that because they're sort of small and move quickly. But a lot of the sort of the judgments we have are kind of built up as we go, right? Why is, one, manufacturer better or worse than another? Well, probably because the advertising has kind of conditioned us, with warm, cozy feelings because of the way in which it's, it's produced the adverts and the associations in the adverts. So I think that in terms of judgment and ethics, in humans at least, pretty much all of it, you can boil down to these kind of emotional reactions or somatic markers that we use to evaluate different states of the world and make our plans, right? So we imagine going to the shops and buying different kinds of food, and some of them will produce a sort of warm, cozy feeling of satisfaction, and others will feel, a sense of revulsion, right? And so getting back to the machines, so probably if we want machines to function like humans, we're going to have machines with some kind of judgments or evaluations of the world, right? And we might try to make those machines kind of learn their somatic markers for the environment, which almost certainly we're going to have to do because we're never going to be able to program some kind of super smart intelligence from scratch. We've tried that and no one's achieved it. These kind of the super intelligence, whatever it is, we'll have to sort of learn about the world by hoovering up lots of data and by experiencing things and trying things out. And otherwise, it's never going to get, even half as smart as people. And so somehow, if you want to protect humanity, you somehow have to be able to have some control over its ethics, if you like, which will be grounded in its emotions to some extent. Yeah. So it'll have positive and negative sort of associations with different states of the world. And you somehow, and this is a very hard problem, going to have to somehow control that it has, positive associations of keeping people alive and not wiping out humanity and keeping itself alive, if you see what I mean. And that's the difficult control problem.
Yeah, but it's a complex challenge because at the end of the day, I mean, if you look at humans, we are still, depending on our identity as a, community, as in our tribe, or, our nationality. So if you look at the machines, even if we integrate the ethics in the code, they would still, as they develop more intelligence, they are going to know that they are not humans. They are machines. They are entirely different intelligent species. So their loyalty is going to be towards machines. Their loyalty is not going to be towards humans because they will consider human as other species. So these complex challenges will need to be figured out because even if we integrate ethics in the code, how are we going to prevent machines to think that they are other intelligent species? Maybe we need to give them an identity. Maybe we need to somehow make them think that they are part of human species. Those things will be very essential for us to prevent them going off track and thinking about just their survival as a species rather than human survival. So again, these are very, very complex challenges, and we will have to come up with some unique solutions to prevent the nature of the disasters that a lot of thought leaders are thinking that is coming our way. But to understand all that, to learn all that, to research all that requires tools and technology. Do you think we have enough tools and technology right now to study all these complex challenges, irrespective of whether it's intelligence, decision making, or consciousness? Do we have enough tools and technology, or we need further advances in tools and technology to help researchers like you, do a better job at understanding these complex, problems and coming up with effective solutions? Where is the advancement? Where are the advances necessary?
Okay, so can I just comment? I'll comment again on the first bit, and then I'll come to the tools and technology stuff. So I guess there's a couple of comments on the first bit. So firstly, a lot of this stuff is way overhyped, right? So, we all watch far too many science fiction films, right? And that technology is way in the future, right? We're currently at this sort of AI revolution, AI resurgence, whatever, 2 or 3.0, whatever it is. But that'll burn out. The deep learning stuff is great, but it's super limited. People who actually don't do AI tend to have a very high opinion of it, whereas if you do it, you see massive limitations in it, and just how bad stuff is still. So there's lots of nice solutions in small areas like object recognition, face recognition, language processing. We can probably do some nice classification of tumor slides and stuff like that. But cognitive systems are way short of the sort of science fiction. And so as an aside, there's some nice work in machine consciousness, which is trying to produce machines that are sort of where they have like a simulation environment that is the machine's perception of reality, if you like, and then they're trying to make these machines sort of think in a way that's more human-like, if you like. So that's the kind of the step after all this AI boom with data science. It's a kind of return to some of the roots of AI and trying to actually figure out systems that are think like more in a more human-like way. And there's a bunch of research still going on with that. So that's the first sort of point I want to make. So the second point I want to make is that people often, generally because the science fiction is biased in this way, tend to think that the AI takeover is going to be this horrific thing, right? And they tend to forget that humans are pretty horrific already, right? So we slaughter each other all the time, run the world badly, got some other bad political systems at the moment. So it's not like it's all peachy now, right? So the flip side of all this is, this sort of dream, probably of the 50s or whatever, of this sort of more rational or better planned society that actually, takes it out of the hands of humans to some extent with their messy, dirty emotions, and all that kind of stuff, right? Because our emotions are pretty messed, right? In many ways, we're not really in control of them, and we're getting whole political systems run by people, based on their egos and that kind of stuff. So, in some ways, this whole AI thing could be has the potential to be not just some kind of apocalyptic robot stamping on the skulls of human stuff, but it could be, Asimov actually in iRobot has a vision of this kind of benign takeover by artificial intelligences, in a gentle way that has lots of bugs. The robots kill a few people, not in Asimov, but they will, and have already, like self-driving cars. But so of course there are bugs, of course there are glitches, but it's a sort of, there is a vision where there's a sort of, coexistence with AIs, and where they get the strengths of the AIs kind of compensate for the human weaknesses and that kind of stuff. And related to that, supposing we could produce conscious machines, like really conscious machines in the same way that we're conscious, yeah? Then we get into this, there's a whole sort of set of tricky ethical issues, not only about how we should treat those conscious machines, but consciousness is within human values, for the most part, something that we respect as a thing. It's almost a source of value, the consciousness itself, right? So people who are conscious, we're not allowed to kill them, right? Whereas coma patients, you can switch the machine off because they're not conscious, yeah. And typically in discussions about animals and how we should treat animals, if an animal is not conscious, then it's okay to treat it however we want to treat it. But if it is conscious, then we've got to respect its rights and all that kind of stuff. So if we have machines that are conscious, let's say, then obviously they're going to have similar kind of rights to ourselves, right? And then you ask the question, well, maybe why would we prefer human consciousness to these machine consciousnesses, right? Maybe it'd be better to have, lots more machine consciousnesses and less human consciousnesses, right? Because they're just the same kind of thing, yeah? And furthermore, I mean, humanity is going to be wiped, when you reach the end of my book, right? It's like humanity is going to be wiped out by the sun at some point, whereas our machine consciousnesses at least can leave the solar system, whereas we can't, right? So if you're looking long term, billions of years, the machine consciousness stuff's the way to go. So to answer the third part of your question about technology, well, obviously lots of cash, is kind of required, right? But I think what a lot of people worry about with all this AIs and this kind of stuff is the problem of unpredictability, because I really don't think as you know, there's some sort of fantasists in this area who think that we can somehow embody the ethics of of machine in its operating system or in the code somehow by like writing a few lines of code or whatever. But a lot of the problems with AI aren't necessarily problems in the application of a set of rules baked into the operating system, whatever that means. They're more to do with misperception or something like that, right? So that the robot, might have the rule that say we've got a killer robot on the battlefield, right? And it has a rule that it must not kill, innocent civilians, let's say, right? But if it's, suppose it's hostiles detection algorithm, picks up yellow jackets, let's say, and all the civilians are wearing yellow jackets, then it'll just machine gun all the civilians as well, right? So there's a whole bunch of problems about misperception or miscognition or misunderstanding that are going to undermine any attempt to kind of write these things into the operating system. And humans are the same, right? We know our ethical codes, but then we, constantly cheat on them all the time, right? There's a lot of data showing that people, will profess, some kind of rigid set of values, but then in fact, they'll bend them and twist them as much as they like to actually do what they want to do in their real lives. Yeah. So robots and artificial intelligence have the same problem. It's a dream to imagine you could bake it into the code somehow. And it's also a dream to imagine you could bake it into the code because, as I said, humans are too stupid to sit down and write, 20 million lines of code or whatever it takes that will be some kind of super intelligent system. We're not capable of that. We can write Linux operating system. We can do some pretty complex stuff, but we've tried and failed to write a super complex AI by itself. The only way, plausibly, that we're going to get a super complex AI or super intelligent AI is by some kind of learning. And there's tons and tons of work of people building robots, and the robots interact with the world and learn about the world through interacting with it, all of which is extremely primitive. But that's really the only game in town in terms of building a system that could actually be more intelligent or as intelligent as a human. Because we're just not clever enough. We don't have the time to write a system from scratch that can do that. We can write limited AIs, and even those limited AIs are mainly based on learning these days.
Well, so neuromorphic computing could change that, right?
Well, yeah, they're based on, they would incorporate learning. So let's say we had a neuromorphic computer, a fairly simple one with 1 million neurons in it, which some people are trying to build. That would still be a system that learned through interacting with its environment. But just to make this final quick point, so since it's going to be based on learning, the whole problem a lot of people who worry about AI ethics are struggling with is how do we know what it's learned, right? So if we've got a self-driving car that learns how to drive its way along the road and then it crashes and kills someone, how can we understand what that self-driving car did so that we can fix it and prevent it from doing it again? And if the self-driving car is controlled by, some kind of super complex deep learning network that just hoovered up a load of data, then it's going to be very difficult to look inside that network and see exactly why it reached the decision that it did. And that's why DeepMind generated all those sort of bizarre, sort of hallucinatory pictures to try and understand what their visual learning networks had learned. But in terms of a deep network that had learned, sort of road speed and all kinds of complex stuff, that kind of visualization is not going to help you. So the plus side of some of the work on machine consciousness is that you can produce a system that's more controlled in the sense that you have some parts of the system, like the visual detectors and that kind of stuff, can be just, black box deep learning stuff. But then the kind of reasoning processes, can be more like conscious reasoning processes. And then potentially you can look inside the mind of the system and understand why it did what it did and get it to articulate why it did what it did. So by building more human-like systems like that, even though they're not going to be controllable, but we might at least be able to look inside them and see why they're acting in the way they're acting, and that might help us to, adjust them or switch them off or whatever we needed to do. So
yes, yes, I think just the way we are trying to embed the ethics in the code, we need to embed security in the code to prevent the future disasters that so many people are worried that once we get technological singularity, irrespective of it, whether it comes through the the deep learning or neuromorphic computing or whichever method it goes through, or whether we get the technological singularity using gene editing. The intelligence, is going to increase, tremendously. The level of intelligence is going to increase tremendously in man and machines both in the coming years. So we do need to come up with, proper frameworks, proper, security controls, irrespective of whether it's, man or machine, so that we prevent the sort of disasters that could happen for the future of humanity. So these are all this is what we are trying to do, develop thought leadership so that we can visualize what could go wrong, where it could go wrong, and how to prevent those strategic security risks for the future of humanity. Having said that, what would you like to tell our global viewers and listeners about your efforts towards understanding consciousness in man and machines, and about your books, where they can get the books so that they can read that, and also what would you like to tell those brilliant students, brilliant young people out there who are trying to make a difference for and trying to solve problems for not only their communities but also for their nations and even for the future of humanity?
Okay, that's a lot of questions, right?
Questions.
Yeah. Okay, so well, just on my books, right? So yeah, obviously, if they're interested in the human and machine consciousness stuff, they can just read it for free online. Just look up "Human and Machine Consciousness" by David Gamez. That's easy. And you'll also, if you just look at my name, David Gamez, you can find like a bunch of publications on that. So that's that question. In terms of and more generally, I'm more than happy to take, masters, PhD students, whatever. So if people want to get in touch and do this kind of stuff, I'm more than happy to work with people or collaborate, that kind of thing. What was the other parts of that question? I should have written it down.
What would you like to tell those brilliant minds who wants to get involved of humanity?
Okay. In terms, well, it depends. Depends what aspect of it, I suppose, right? So, I mean, there's a bunch of, I think it's fairly easy these days. There's a lot of, very nice tools around. I mean, just on the pure AI side, right, that you can use to do lots of different fun stuff. I mean, what's really good about the world today, I mean, I haven't done any of this kind of work in developing countries, let's say, but, I imagine that if you've got access to a computer, you can pretty much do all the stuff that anyone anywhere in the world can do, right? So, I've been teaching my students about using the cloud and deep learning in the cloud and all this kind of stuff. And, anyone can do that anyway, right? You can just get hold of, an account and just use that kind of stuff. So the technology is there to, for anyone to take hold of that technology and learn, because there's like a million different resources. So we're living in a kind of golden age of applying technology to different problems in the world, and I think that's great. And I think, just to reflect back a little bit, the whole singularity thing, I think, is again one of these sort of slightly overblown things. I mean, a few people are working on, machine programs that become smarter, but as it happens, I think we're only going to get a decent technological. One way to get the technological singularity is to have some kind of better way of measuring intelligence, right? Because if we can measure intelligence with an algorithm, like we're talking about with the measuring consciousness, then we can train a system to perform better against the measure of intelligence, right? We can use genetic algorithms where you can produce like 10 different systems, and you measure the performance of each of them using your intelligence measure, and then you kind of crossbreed them, and then you produce another set of systems, and then you keep doing that. So if you've got a measure of intelligence, you can potentially produce the singularity, because you can get increasingly intelligent machines through genetic algorithms or some kind of other mechanism like that. So on the bright side, that's what I'm working on next, right? I kind of like the idea of having a measure of intelligence based on predictions. So that's currently one of my summer project. We'll see how it goes. So that's, just fun stuff really. But, but that's the thing so people should start worrying about the singularity when we actually have some plausible attempts at the singularity. The singularity is not going to just happen, out of a box, out of nowhere, right? There'll be like 20 different bad programs that kind of get a bit more intelligent and then fall out. There'll be some programs that run out of resources and so on and so forth, right? So I think we can worry about the singularity nearer the time, so to speak. And just another comment I wanted to make. As it happens, the most dangerous machines and computers in terms of threatening humanity, it hasn't been the intelligence of the machines, it's been the bugs in the machines, right? So there's been at least one, there was that famous, The Man Who Saved the World, right? There's a documentary film about a Soviet guy working, I think it was the early 80s or late 80s, can't remember. There was a bug in the early warning system of the Soviet, nuclear defense, right? So it looked as if there was a massive nuclear attack coming from America, yeah, because of a bug in the system. So, if this man had sort of gone according to protocol, they would have launched a massive counterstrike, which would have triggered the real strike, and we'd have been, annihilated, basically. But that's why he's called the man who saved the world, because he made the call that, even though the experts say it's not a software error, I think it probably is a software error. So let's not, try and obliterate the Americans at the same time. So, and I think there was a similar problem in some of the American, launching systems. So those kinds of bugs, are a massive threat to humanity, right? Because, they could completely wipe us out. Whereas at the moment, the AIs are a lot less of a threat. And they become more of a threat in the future, not because they're going to become super mega intelligent and take us over and crush our skulls and all that kind of stuff, but probably because the problem I was talking about with the self-driving cars, that they'll have learned a load of stuff, so we'll kind of mostly trust them, and we'll put them in charge of more critical systems, but then they'll probably have learned some really strange stuff that maybe we won't pick out in the testing, and then that really strange stuff will come back to bite us because they'll make bad decisions based on this, misinformation that they've got. And that won't be because they're super intelligent, but just because they've learned from the world, and it's very difficult to test and control systems that learn from the world.
Right, right, right.
So in terms of the people out there, so to speak, yeah. So I think the best thing to do is learn computer science and get involved, right? Because there's tons of fun things to do with that.
Yes, it's the best advice anyone can give right now. Everyone needs to learn computer science, irrespective of the age, whether you're young or middle-aged or old, senior citizens. Everyone needs to learn computer science for our survival and security, I would say.
And philosophy as well, I must add. Because I think computer science is really important because it gives you the skills to be able to model stuff and change stuff. But if you don't actually think about what you're doing, for example, through philosophy, then you're kind of not going to do so well. And so I think really actually an interdisciplinary perspective is definitely the strongest one, right? So you need to know some stuff about biology and some stuff about computer science and some stuff about, philosophy or whatever it is. Yeah. So, that not to be too narrow either is obviously a threat to humanity, right?
Very true. We would say, STEM, science, technology, engineering, math, everyone should focus on that because the coming tomorrow is going to require all those skill sets. So thank you so much, Professor Gamez, for participating in Risk Roundup today. Our global viewers and listeners would benefit tremendously from the understanding you provided on both man as well as machine consciousness. So even if a single individual or entity is able to benefit from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Okay, well, thank you for inviting me.
Wonderful, Dr. Gamez. So Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, aquaspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threat and peace to the management of conflict, risk management is related to the management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security. So if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup webcast or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayshree, host of Risk Roundup, signing off. See you next time. Thank you.